दुनिया सर का हल्ला है बीपटा हुए नहीं अच्छा आम इक्विलिब्रियम शुणुचे थर्मोडायनामिक्स रे गोटे जिनस तुम पढ़ बुझल इक्विलिब्रियम टा भी पढ़ा दरकार वॉल्यूम प्रेशर और नंबर ऑफ मोल्स और टेम्परेचर या नहीं गोटे कॉन्सेप्ट अच्छी तुम स्टेट्स ऑफ मैटर रे PV इक्वल टू एनआरटी पढ़ आइडियल गैस इक्वेशन आइडियल गैस ये सब विषय पढ़ Bell's law, Charles law, Avogadro's law mainly सब अन्य जिनस अच्छी ना पढ़ so you come to last the equilibrium of the particles is very important you know the each for example equilibrium the role ta kon for example it was in the each equilibrium ta equilibrium involving O2 molecules and the protein hemoglobin play a crucial role in the transport and delivery of O2 from our lungs to our muscles. Similarly, equilibrium involving CO molecules and hemoglobin account for the toxicity of CO. When the liquid evaporates in a closed container, molecules with relatively higher kinetic energy escape. देखो evaporation नो तुम 9th grade पढ़िथिलो escape from the liquid surface into vapor phase and the number of liquid molecules from the vapor phase strike the liquid surface and are retained in the liquid phase. दीटा कथा कहूची जितेबले evaporation चालू हबो सेतेबले कोन हुए ना गोटे माने केतेबले मॉलिक्यूल जोडाकर हायर काइनेटिक एनर्जी अछि सोडाका सरफेस टू एस्केप करिया लिक्विड सरफेस दैट इज इवेपोरेशन वेपर फेज को एंटर करिया बुझियला एस्केप कोई कुआड जानते ना वेपर फेज रे पहुंचिया गैस ही नथि द वेपर स्टेज रहता है तापरे से कहूची फ्रॉम द वेपर फेज स्ट्राइक द लिक्विड नंबर ऑफ लिक्विड from the vapor phase strike the liquid surface and are retained in the liquid phase. It gives rise to basically liquid रोती आओ जाई पारंती it is a closed container जदि एटा क्लोज कंटेनर न होई थांता ताले उडी की पळै था माडा होती माडा की लिक्विड सरफेस माडा तो वेपर फेज को जिबे पुन लिक्विड फेज को पळै वेपर फेज को जिबे लिक्विड फेज को पळै माडा so the second it gives rise to a constant vapor pressure because of an equilibrium in which the number of molecules leaving the liquid equals the number of returning to the liquid from the vapor. No? ଯେତିକି ଯାଉଥିବ ସେତିକି ଫେରୁଥିବ କ୍ଲୋଜ कंटेनर କଥା ପଢିଛି ଓପନ କଥା ଭାବିଲନି ହେଲା that is equilibrium it କହୁଛି we say that the system has reached equilibrium state at this stage ଏଠି ଗୋଟେ ସିଷ୍ଟମ ଆଉ ସରାଉଣ୍ଡିଂ କଥା ବାରମ୍ବାର କହିବ ସିଏ ଥର୍ମୋଡାଇନାମିକ୍ସ ରେ କହୁଛି ଗୋଟେ ସିଷ୍ଟମ ର ପ୍ରେସର ଭଲ୍ୟୁମ टेम्परेचर नंबर ऑफ मोल्स विभिन्न जिनिस अछि तार सब एवडा चेंज हो गोटे रिएक्शन ता चालू गोटे बिकर भीतर अछि जे मिक्सचर टा दैट इज सिस्टम तो बिकर बाहर बा बिकर जोते तिया काचर तिया सेटा होछि द सराउंडिंग तार मार्जिन भी बाउंड्री पॉइंट भी अछि बाउंड्री पॉइंट कोड ना बिकर रो ग्लास टा वॉल को जाय सेटा adiabatic process अछि isolated system अछि सब पढिबो बुझियो विभिन्न सिस्टम अछि सराउंडिंग अछि त सब so it is saying a system what it has the देई देबी thermodynamics 42 पेज अछि ना 42 के 30 समथिंग का अछि केमिस्ट्री बहुत बड़ा बड़ा अछि however this is not static equilibrium and there is a lot of activity at the boundary between the liquid and the vapor thus equilibrium the rate this is thus at equilibrium the rate of evaporation is equal to the rate of condensation. It may be represented as like this. L web. The symbol is. The double half arrow indicates that the both processes in both the directions are going on simultaneously. The mixture of reactants and products in the equilibrium state are called equilibrium mixture. ଯଦି ଆସିବ କୋଉଠି diabetic ବା isolated system କିଛି ଆସିବ ମାନେ ମୁଁ ତ ତାର ଗୁଡେ ଜିନିଷ ଅଛି internal energy ଅଛି enthalpy ଅଛି ବୁଝିଲ ନା enthalpy ସେଇଆ ସେ ଯୋଉ ଜିନିଷ ଆମେ ପଢୁଥିଲେ ନା ତାପରେ ହଁ ସେଇଆ ତ enthalpy ଅଛି କୋଉଟା positive କୋଉଟା negative ହବ in that case heat ଗୋଟେ ଅଛି heat capacity ଅଛି specific heat concept ଅଛି ସେ ସବୁ ନେଇକି ଇକ୍ୱେସନ ସବୁ ବନିଛି ସହଜ ଇକ୍ୱେସନ ସବୁ ଇଣ୍ଟିଗ୍ରେସନ ବି ଅଛି ଦେଖିବା ଯୋଉଠି ଆସିବ ମୁଁ ଟିକେ ରିଟର୍ନ ବ୍ୟାକ୍ କରିଦେଇଛି ଥର୍ମୋଡାଇନାମିକ୍ସ ବହିଟା ଏଠି ଲୋଡ କରିଦେଲା ବା କରିଦେଇଥିବା ଦରକାର ମାନେ ଇଏର ଯୋଡର ଦରକାର equilibrium can be established for both physical process and chemical process chemical reactions. The reaction may be fast or slow depending on the experimental conditions and the nature of the reactants. When the reactants in a closed vessel at a particular temperature react to give products, the concentrations of the reactants keep on decreasing. It is an important point. Keep on decreasing, while those of products keep on increasing for some time, after which there is no change in the concentration of either of the reactants or product. This state is the dynamic equilibrium. Reactant कभी जाऊँगी closed container. This is all about the closed container. Suppose a closed vessel. It's very important. तमें ये जिनिस गुड़ाक मुंडे रखिबो. Otherwise concept बुझिबा भारी कष्ट पड़िबो. Starting रू ठीक जिनिस गुड़ा धरतिबो. से closed container भितर जो reaction होती reactant रो concentration कभी जाऊँगी product रो concentration बढ़ गई है. गोटे stage रे एमती होची आउ किसी change हो. Standstill. That is the state of equilibrium. Dynamic equilibrium. It is due to the dynamic equilibrium states that there is no change in the concentration. Based on the extent to which the reactions proceed to reach the state of chemical equilibrium, this may be classified into three groups. Chemical equilibrium. Based on the extent to which reactions proceed to reach the state of equilibrium, chemical equilibrium. The states and the rates of the forward and reverse reactions becomes equal. It is also very important. Because it is due to the dynamic equilibrium. तो यही जिनसटा से केमिकल इक्विलिब्रियम में नाम होची बुझिलो ना सो यार तीन प्रकार फेज होची तीन प्रकार क्लासिफिकेशन से होची reactions छोड़ा reactions that proceed nearly to completion and only negligible concentrations of the reactants are left. In some cases, it may not be even possible to detect these experimentally. Reactants in which only small amounts of products are formed and most of the reactants remain unchanged. सब equilibrium stage रे तीनटा जिनस देखिବାକୁ मिले equilibrium है जो dynamic और chemical equilibrium achieve कर जो तीनटा situation भितर कौन सा situation नो See reactions in which the concentrations of the reactants and the products are comparable when the system is in equilibrium. Comparable. And reactants will be किसी concentration थिबो, product will be किसी concentration थिबो. The extent of a reaction in equilibrium varies with experimental conditions as concentrations, reactants, temperature, etc. Optimization of the operational conditions is very important in industry and laboratory so that equilibrium is favorable in the direction of the desired product. जो product obtain करछो equilibrium टा सही आड़की directed हवा दरकार. अगर theory अच्छी आगो numericals. Some important aspects of equilibrium involving physical chemical processes are being dealt in the unit. Along with the equilibrium involving avoidance of ions in aqueous solutions, which are called ionic equilibrium. Equilibrium in physical process. Phase transformation process. The most familiar examples are phase transformation. Yes. Solid liquid equilibrium. Insulated. Kept in water, kept in ice and water. Normal flask. No exchange between its contents and surroundings. At 273. Go. ना बहुत समय रहेगा. बहुत समय रहेगा. धीरे आपो. बहुत धीरे आपो. अरे जो पोलर आइस कैप्स गुड़ाक अच्छी तब कहबो विराट बड़ धर पत्थर विराट बड़ पहाड़टा भांगिगला भांगिकी पानी को पड़े आसला समुद्र पानी सारा 3/4 पानी बुड़ी जाए 1/4 ऊपर देखा जाता सेटा पहरी 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 आसिक इक्वेटर एरिया में पहुंचीगला बट सेटा पूरा तरल कहीं केते समय लगे केना सेटा को तार जो लेटेंट हीट अप कोन कर मेल्टिंग बहुत प्रबल साइज जटिक बड़ प्रबल हिट दरकार सेतिक हिट कौन सूर्य किरण पड़ुछ पानी बुडिक रही 3/4 जैसा इनिशियल टेम्परेचर अचीव भी करी कर बहुत गरम टिके बहुत दिन मास धरिकी पड़ता है बट हाँ and the atmospheric pressure are in equilibrium state and the system shows interesting characteristic features. Mass of ice do not change with time and the temperature remains constant. However, the equilibrium is not static. Equilibrium is static. The intense activity can be noticed by at the boundary between the ice and the water. Molecules from the liquid water collide against ice and adhere to it, and some molecules of ice escape into liquid phase. किसी पानी की liquid अवस्था में पड़े किसी molecule. There is no change of mass of ice and water as the rates of transfer of molecules from ice into water and of reverse transfer from water into ice are equal to at atmospheric pressure. जितनी पानी इसी प्रकार से चेंज होला कसी कुछ the rates of transfer of molecules from ice into water are water से जिनसटा सेम रोच are equal at 1 atm pressure normal temperature pressure जोड़ा हुआ है ना Huh. It is obvious that ice, water are only at particular temperature. Particular temperature rise at a possible. Temperature, pressure. For any pure substance, theorem, for any pure substance at atmospheric pressure, the temperature at which the solid and liquid phases are at equilibrium is called the normal melting point. Melting point भी define करा के pure substance है तो atmospheric pressure, the temperature at which the solid and liquid phases are at equilibrium. ठीक है
normal freezing point और melting point को हम
हाँ से कौन ना normal melting point କେମିତି ଅଲଗା ସେ ସେଇଟାକୁ ଅଲଗା ତ ନିଶ୍ଚିତ freezing ଆଉ melting ଅଲଗା
ये गोटिए definition
हाँ point of the substance देखो 0 degree ice और 0 degree water हाँ? Both the opposing processes occur simultaneously melting and freezing daytime both the processes occur at the same rate so that the amount of ice and water remains constant. Huh? It is all talking about the closed vessel, the insulated closed vessel, that is thermos.
ये पूरे टॉपिक का क्लोज कंटेनर से नहीं है
नहीं suppose liquid है ना solid liquid का सब पड़ेगा अगर liquid है ऊपर हो जाए ना ना मतलब stream को पड़ेगा steam ना can be better understood if we consider the example of the transparent box carrying a U tube with mercury manometer. Drying agent like anhydrous calcium chloride or phosphorus pentoxide is placed for a few hours in the box. After removing the drying agent by tilting the box on the one side, a watch glass containing water is quickly placed inside the box. It will be observed that the mercury level in the right limb of the manometer slowly increases and finally attains a constant value. That is, pressure inside the box increases and reaches a constant value. It is very important. Pressure भी constant रहुଛି. खाली theory गुड़ाक. The box increases and reaches a constant value. Also, the volume of water in which watch glass decreases. हाँ सही है. So देखो जो तब है. The volume of water in the watch glass. तो देखी वो तब. ना. Because 1.1 ने देखी थी वो ना. It double. Initially, there was no water vapor or very less inside the box. As water evaporated, the pressure in the box increased due to addition of water.
सर anhydrous calcium chloride का वाटर भी है
नहीं anhydrous calcium chloride water कैसे डिग्रेड कर लिया ड्राई था ना anhydrous हाँ किसी सब अब तो अगला परसेंट एक्यूएसी ऐसे कौन the rate of evaporation is constant. However, the rate of increase in pressure decrease. with time due to the consideration of vapor into body. Finally, it leads to an equilibrium condition. Today the tank of 877. No net evaporation. This implies that the number of water molecules from the gaseous state into the liquid state also increases till the equilibrium is attained. Equilibrium achieve न होगा कौन से जिनसे बड़ी बड़ी जाए जो equilibrium है ना जिससे साइंस बुझिए ना लिखिए ଆଉ କଣ H2O liquid vapor जिनसे लिखते ना खाली equilibrium ର property जोड़ा ଦେଇଛି is the pressure exerted by the water molecules at a given temperature remains constant and is called the equilibrium vapor pressure. Simply just vapor pressure of water. Vapor pressure of water increases with temperature. If the above experiment is repeated with methyl alcohol, now another liquid oil, methyl alcohol, acetone and ether, it is observed that different liquids have different equilibrium vapor pressures at the same temperature. So, विभिन्न liquid और विभिन्न रहुची pressure difference रहुची vapor pressure टा समझते same रहुची. And the liquid which has a higher vapor pressure is more volatile and has a lower boiling point. जल्दी boil करें जल्दी evaporate करें. Better a higher vapor pressure होची. ये relate करके मारने के. प्राइस में देगा आओ देखो सॉरी जी पाओ हाँ मेरे रिकॉर्डिंग का बंद कर दिया